And welcome back. So today, we're going to do some examples of a couple more complicated styles of line questions, or maybe they're not actually super complicated, but we just want to be careful that we're prepared for whatever comes up. So here we have a question about a line passing through 2, 3, and 5, 9, and the question is, what is its X-intercept? And so this might originally be startling, because we've never probably seen this combination in a question before. We're given 2 points and asked for an X-intercept. But generally, any question that asks you something about a line, the first thing you want to do, if you can, is find the equation of the line. And then reassess. And the hope is, of course, that once you've found the equation of the line, then you can look at what's going on, and then you can figure out how to do it. But in the worst case, you find the equation of the line, and then you can at least get partial credit for getting part of the way through what the question asked. Okay, so in particular, we've sort of boiled this down. What we want to do is find the equation of the line that goes through 2, 3, and 5, 9. Okay, so we go to calculate our slope. And we take the change in the output, 9 minus 3, divided by the change in the input, 5 minus 2. So from the point 2, 3 to the point 5, 9, the output went up by 6, that's the 3 to the 9, and the input went up by 3, that's the 2 to the 5. And so the slope here is 2. Just in case you're curious, it doesn't matter what order you use the points as long as you're consistent. So I always do second point's y minus the first point's y, and then divided by the second point's x minus the first point's x. You can do it the other way around. You just have to do the same thing for both the y's and the x's. All right, so having done that, we know that the equation of our line looks like y equals 2x plus b. And then we just have to figure out what this b is going to be. And so to do that, we can plug in our choice of these points. So I'll plug in 2, 3. Because since 2, 3 is on the line, that means if I plug in 2, 3, I'm going to get a true equation. So I will get 3 is 2 times 2 plus b. So that is 3 is 4 plus b. So that tells me that b is minus 1. Okay. And so our line is y equals 2x minus 1. Okay, so if I recall, my outline here was, okay, we'll find the equation of the line first, then reassess. We found the equation of the line, we now need to reassess. Really, now what the question is asking is, what is the x-intercept of y equals 2x minus 1. And so here, I have to ask myself, what's an x-intercept again? And what is an x-intercept? An x-intercept is a point where y is equal to 0. So really, what this is asking is, hey, what's the point on this line, y equals 2x minus 1, where y is 0? And so to do that, I just set y is equal to 0 and solve. And I get that this happens at x is 1/2. Now, remember, we always want to list our x-intercepts and our y-intercepts as points. So that is to say, we want to list it with the x-coordinate 1/2, comma, and then the y-coordinate 0 because it's an intercept. And so that is our answer to this question. Okay, so here's another variation of a question that we might not have thought about before. We're given 3 points on a line now, but one of the points has an a in it, so this is a variable. And then the question is, what's the value of that variable? But I want you to remember the same piece of advice that I had in the last problem, which is that, well, if you don't know what to do, just find the equation of the line first, and then once you've found the equation of the line, then ask about the other part. In this instance, I can definitely find the equation of the line just by looking at these 2 points, which means I get to not think at all about this business with a point with an A in it and what A is. I can just think about these 2 points and say, aha, I know what the equation of the line through these 2 points is, or at least I can find it. So I can calculate the slope. The change in the output will be 7 minus 3 divided by 6 minus 2. So that is plus 4 over plus 4, which is 1. So my slope is 1. So my line looks like y equals 1 times x plus b, which I'd usually just write as y equals x plus b, since 1 times x is x. And then I could plug in one of these points. I can plug in, say, 2, 3. And I will get 3 is equal to 2 plus b. So b is 1. And so that means the equation of my line now is y is equal to x plus 1. Given that we now have the equation of the line, I can now forget about that part of the question and really say, okay, the question now really is, the point A12 is on the graph of y equals x plus 1. What's A? And restating the question like this, once I know what the line is, again makes it more clear what's happening. Namely, this 12, this is the output, it's the y-coordinate. So what this is really asking, you could phrase this a different way, what input gives you the output 12? But whichever of those ways you prefer to think about this, I'm saying if I set y equal to 12, then what's x? So I'll go ahead and put 12 is equal to a plus 1. And so a is 11. And that is our answer. So this is a fairly common style of question to appear in the homework. You've got some graphs layered on top of each other, and you have some point labeled. In this case, that point is question mark, and we want to find what the coordinates of that point are. Now, I want to follow the same advice that I followed before, which is that before I can do that, there's a line here. I want to find the equation of the line. Now, I know one point on the line is 0, 2. So in particular, I know that the y-intercept of the line, in fact, happens to be b equals 2. But at first, it's not super clear how I'm going to find either a second point or the slope. I mean, technically this point is on the line, but my goal is to find this point, so that's not going to help me find the equation of the line. Instead, what I actually have to notice is this point. And there's two special things about this point. Okay, the first thing about this point is that it's on our line. But there's a second thing about this point that you can notice. Namely, this point, it's also an X-intercept of the parabola. And so, I can find the X-intercepts of this parabola to find what this point is. So now I have entered into what I like to call a subproblem, which is just a problem within a problem. Namely, the subproblem I've entered into is, what are the X-intercepts of y equals x minus 1 times x plus 2? Well, X-intercepts, remember, are the points where y is 0, so I can set 0 is equal to x minus 1 times x plus 2. And in this instance, the fact that this is already factored for me actually makes my life much easier, because I have 0 already is equal to this product of two things. So I can split this up and say, okay, so this is x equals 1, and this is x equals minus 2. So there are actually two X-intercepts on this graph, okay? And I can see the other one. The other one is there. And I have to take a moment to sort out which of these is which. Well, this one has a positive x, so it has to be that this point is 1, 0. And then this one has a negative x, so it has to be that this point over here is minus 2, 0. Okay. With me so far? Now we used what we wrote down as point number 2 here, that this point is an x-intercept of this parabola. But now, point number 1 is helpful, because this point we now know is minus 2, 0. And so minus 2, 0 is on our line. And so since minus 2, 0 is on our line, and 0, 2 is on our line, I can use these 2 points, minus 2, 0 and 0, 2, to find the slope of this line. Okay. Namely, when I go to find the slope, it's going to be 2 minus 0 divided by 0 minus minus 2. Which is to say, it's plus 2 divided by plus 2, which is 1. Now, if you remember earlier, I noted that this was the y-intercept of our line, so I can jump straight to that the equation of our line is y equals x plus 2. Now, as it happens, we're not done yet, because remember, we were given a question and it was a weird question, so we decided, okay, first things first, let's go ahead and figure out what the equation of the line is. Now we know the equation of the line. Now we have to reassess and figure out how, given this equation of this line, I'm supposed to find this point. And what is special about this point? Well, you might notice at this point, the point we're looking for, the line and parabola intersect. And we went over in the last section how to find the points where two graphs intersect. Namely, we want to take the graph y equals x plus 2 and y equals x minus 1 times x plus 2. We want to know where they intersect. We're going to do that by equating the outputs of these two things. Namely, to find the intersections, we're going to set them equal to each other. That is, I'm going to take x minus 1 times x plus 2 and set that equal to x plus 2. Okay. Now, when we started the question, we couldn't possibly have done this because at the time we started the question, we didn't know the equation of the line. But now that we do, we can set this equal to that and go about our business. Now, unfortunately, the fact that this is written like this is a hindrance rather than a help, because I don't have a product equal to 0, so I have to FOIL out the left-hand side here, which will give me x squared plus x minus 2 equals x plus 2. I can go ahead and move this over here, so the x's will disappear, and I will get x squared minus 4 equals 0. And then I can move the 4 back over, which is what I'll do. I'll say, okay, so x squared is 4, and so then x is plus 2, or x is minus 2. Remember that when you're solving x squared equals a number, you get both a plus square root and a minus square root in this case, because both plus 2 and minus 2 square to be 4. So this is the x-coordinate of our point. Wait, is it? Which point is this the x-coordinate of? That's right. This point is the x-coordinate of this intersection. Okay. What we actually found here is that, in fact, the parabola and line intersect in 2 points. One of them is this minus 2, 0, which is not the point that we want. And so the other one, the one with x is positive 2, that's actually the point we're looking for. And so we can go ahead and fill in. That question mark is 2. How do we then find the y-coordinate? Well, the way we find the y-coordinate is by plugging in the x-coordinate. Because again, this x is plus 2, that's the input. I want to find the matching output for 2. The easiest way to do that is to look at this y equals x plus 2. So namely, this will be 2 plus 2, so this point will be 4. And so 2 comma 4, that's my answer. If you liked, you could have just as easily plugged the 2 into x minus 1 times x plus 2, which would have given you 1 times 4, which would have also given you 4. Okay, so here's one last kind of line question that I think looks intimidating, but is actually not so bad. Namely, you're given, again, much like in the last question, a line and a parabola. In this case, you're told the graph parabola is just f of x equals x squared, or that's the function that this parabola is the graph of. Okay? And we're asked to find the equation of this line. Now, I see that I have 2 points on this line already, but I don't actually have their full coordinates. But what this is indicating to me is that the x-coordinate of this point is 4, and likewise the x-coordinate of this point is minus 2. So I only need to find the y-coordinates. And the thing I can do to do that is I can use the fact that both of these points happen to also be on the graph of f of x is equal to x squared. Namely, I have here the input 4, and I want to know what output that corresponds to. Well, that corresponds to the output, f of 4, which is 4 squared, which is 16. So this point here is 4, 16. Likewise, over here, I have an input of minus 2. What output does that correspond to? It corresponds to f of minus 2, and that is 4. Note it's positive 4, because the square of a negative is always positive. And once I've calculated the output of this function at these 2 points, I can now completely forget about the parabola. I don't need it anymore. I just know I want the equation of the line that passes through these 2 points. So, at this point, we forget the parabola and just look at the 2 points on the line. So to start with, let's write down the slope. The slope here of the line between these 2 points is going to be the change in the output divided by, and then the change in the input. Okay, so that is going to be plus 12 going from 4 to 16, and plus 6 going from minus 2 to 4. Okay, and so my slope here is going to be 2, which means that my equation is going to look like y equals 2x plus b. And I need to figure out what this b is. And so to do that, I get to plug in either of these 2 points. I guess I'll plug in the 4, 16 one. And so that will give me 16 is equal to 2 times 4 plus b. And so I will subtract this over, and so I will get that b is 8. And so the answer is that the equation of the line in this picture is y equals 2x plus 8. All right, I'll wrap up this video here. In the next video, we're going to talk about parabolas. And there's not a whole lot to say about parabolas, but we'll go ahead and talk about it quickly. But for now, I'll see you in the next video.